For most of us, this is the first image that comes to mind when we think of mathematics: a chalk dust-covered board, an impossible equation, and that sinking feeling in your stomach when the teacher calls your name. Yet, while you might freeze up during a pop quiz, your brain is secretly a mathematical powerhouse. If someone throws a baseball at you, you don't stop to calculate its trajectory on paper. Your nervous system handles the complex physics in milliseconds, guiding your hand to the exact point of impact. Society frames mathematics as an artificial code, a rigid set of academic rules invented by ancient scholars that must be forcefully memorized to pass a grade. But biology tells a different story. Wild animals track quantities to find the best food sources, and human infants show a clear understanding of basic addition and subtraction months before they can even speak. These instincts suggest a radical shift in perspective. Perhaps mathematics isn't a cultural language we invented, but a physical, biological sense we've carried with us since birth. To find the actual proof for this, we have to look closely at the biological hardware working inside our heads. Deep within the parietal lobe is a specific fold of tissue called the intraparietal sulcus. This is the brain's dedicated circuit for numerical calculation. Whether you are estimating the size of a crowd or choosing the shortest line at the store, this region is doing the heavy lifting. This area powers a biological trait called subitizing. It's the reason you can look at 3 apples on a table and know the exact quantity instantly, without having to consciously count them one by one. This chart visualizes a classic study in infant cognition. If a researcher hides one toy behind a screen, adds a second, but then secretly removes one, the data shows the infant stares significantly longer at the result. Even at 5 months old, the brain identifies the mathematical impossibility. We enter the world equipped with a foundational number sense, a biological operating system that calculates the world around us automatically. This hardware has a limit, though. We can only instantly subitize up to about 4 items. To bridge the gap between these primal instincts and advanced subjects like calculus, humanity had to find a clever workaround. We developed a cognitive bridge by inventing visual symbols, like Arabic numerals, to represent abstract amounts our biology couldn't visualize. We effectively hacked our brains, mapping these symbols onto the ancient neural network used for tracking quantities. This mental shortcut allowed us to scale basic instincts into high-level logic, transforming a sense for a few into the precision required for global technology. It's the same pathway. The instinct a bird uses to choose a bush with more berries is the exact foundation we use to mathematically calculate the lunar landing. All advanced mathematics is the result of modern cultural software running on 300-million-year-old biological hardware. Because we share this hardware, the idea of the math person is a myth. Scientifically speaking, if you have a functioning parietal lobe, you are built for calculation. There is a specific exception called dyscalculia, where the parietal lobe develops differently, making it difficult to process quantity. But for the vast majority of people, the machinery is already there, ready to be used. Mathematics should be viewed as an internal evolutionary survival tool, not an external academic hurdle. It is a sense, like sight or hearing, meant to help us navigate reality. Every time you catch a ball or judge a distance, you are participating in a multi-million-year legacy of biological precision. Our biological makeup ensures that we are the physical embodiment of the numbers we study. We are the calculation in motion.